Okay, guys, we'll get started. First off, I would like to welcome everybody to Broome-Tioga BoCES Computer Aided Design, CAD, and 3D Animation, our virtual visitation today. We're going to be going today from about 12:30 to 12:55 and just talking about different things with careers in CAD. So first off, I'm hoping that everybody knows by now, especially from using or seeing this screen here, that CAD stands for Computer Aided Design. And I love the name of the program because it totally 100% defines what we're about. In other words, we are using the computer to aid us in doing design. And that is an awesome thing. Before CAD, all types of engineering and architectural drawings were done on the drafting board. And so CAD has just totally revolutionized the career field and just made it way more creative and way more accurate and way more fun. So I have this PowerPoint that I just want to go over with you guys real quick. So just bear with me. We will get right to it. Okay, so how BoCES works. So what you guys will be doing is, any student who takes this class will either come in the morning or the afternoon. And when they are here at BoCES, they will be, here for the full either morning or afternoon, about a couple hours each session, and they will work on their projects and do what they need to do here for 2 years. When a student is not here at BoCES, then the rest of the day they are at their component school. It's important to know that your school will provide 100% of your transportation, so you don't have to worry about getting here. And I think that that's a real important thing. It takes a lot of the pressure off, for students, especially those students coming from quite a distance away. Students receive 3 credits for every year that they're here. And, if they successfully pass the class, then they get, 6 credits for both years. So daily work, this is just some of the things students can expect to do in this class. So first off, what we do in here is create drawings. That is what our main thing is. And we are creating drawings and preparing for careers in CAD. And most of those careers definitely have a requirement for either creating architectural or engineering drawings. So architectural drawings, architecture is just the design of buildings and structures. Engineering is everything else. Some mechanical parts, automotive parts, mechanical systems, electrical systems, everything else that needs to be created or manufactured is done with engineering CAD. And in saying this, it's important to know that every single part of our curriculum is really based on integrating math, science, and English into all aspects of the curriculum. So this is truly a career area where traditional academics really are used, in the career. So I've had so many students tell me in the past that they always thought that English or some, math, some of their traditional academic courses, their main thing was, well, how would I use this in the business world, in the real world? And in our situation here, we point to numerous examples where it's used all the time. So very, very important to understand that. At the end of their second year, or which is known as CAD 2 here, so 2-year program, first year would be CAD 1, second year would be CAD 2. Students complete a 1.5 year long CAD 2 or senior exit out research project. So students right now have begun putting the first steps into starting their projects this year, and then they're due towards the end of the school year around May timeframe. And this is a research project that is 100% based on what a student chooses their career plan to be. Some teacher information and my experience. My name is John Caminetti, and this is going to be my last year teaching here at Broome-Tioga BoCES. So I will be retiring at the end of this school year. So the program is going to continue with a new teacher. So I would definitely ask that all students, that are thinking about enrolling, if you do enroll, please, show the new teacher, just respect and, cooperation. It's definitely tough being a new teacher, and it'll mean a lot to the teacher if, they have cooperation and respect from the students. So, please, try and keep that in mind, and, know that if you do start next year, be really part of a groundbreaking kind of new year as far as establishing, with a new teacher in this program. So that's, my hope that that happens for next year. So the program is a 2-year program, and it prepares students for exciting and high-paying professional CAD careers. And I've had students in the past say, well, should high paying be important in a career? And I would like to say that it should be, any type of work that we do, work is work. So, when you're leaving your house and you're going to work, it very definitely, should be a thing where salary should be a consideration. In other words, is this the type of career that will pay for, a person to have their own place and have their own car and all the expenses that life requires. So CAD is high paying. And the reason why, CAD careers are high paying is because there's a lot of responsibility in CAD careers. No matter what you're designing, there's just a lot that's connected to the drawings that we're doing. For instance, if you design a building, people will expect that building to not fall down, to be able to stay warm in the winter, to not cost, $10 million a minute to heat or cool it, to be safe for the people that occupy it. And so all those things are expected of CAD professionals in the architectural field. So there's a lot of responsibility in these careers, and that's why they pay so well. The best thing about BoCES is that students can seek employment right after BoCES, or they could advance their studies, by going on to college. And it really will be 100% your choice. And CAD offers career fields that very definitely can be sought after right after leaving this class, or if somebody chooses to go to college. And for instance, if somebody left here and they wanted to work in an architectural firm, they could be an architectural drafter. They could probably expect to start out maybe about $40,000 to $45,000 a year, which translates to roughly about $20 an hour. If they decided, though, that they were really serious about the architectural field and, let's say, wanted to go and get a degree as an architect, which would require about 5 to 6 years of college after high school, they could expect that salary then to be like, $70,000 or $80,000 a year to start, which is like, $30 an hour, so it just really depends on, what somebody wants to do, so 100% a student's choice on, what they want to do and what type of career they want to pursue. This is considered a non-traditional occupation for women. However, some of my most talented students in here have been female students. And please know that in all BoCES programs, that all students are welcome into all of our programs. So gender means nothing. All that matters is that students are dedicated to doing the work. The equipment and uniform, just your regular high school dress and attire will be fine during days here at BoCES. However, CAD careers, once you start working in a career, will require professional business dress and attire. And there are a few days during the school year where I may ask you guys to, the teacher who comes here may ask students to dress in professional business attire. A lot of it depends if maybe a guest speaker might be coming into the class or a potential employer, something, where students would want to put their best foot forward. So just want to make you guys aware of that. One of the nicest things about BoCES is that we work with people in our community and in the industry that we meet with a few times during the year, and they let us know that we are teaching the correct information and skills that employers are looking for. And I just have a fantastic trade committee, or we call them also advisory committees. So I have members of higher education. I have Shelley Cordisco and Michelle Snyder as part of my committee. They are professionals at SUNY Broome, and Michelle Snyder is the dean of all their really technical and engineering programs. And Shelley Cordisco is the director of sponsored programs there. And so a lot of our students leave BoCES and go to SUNY Broome. And so it's really valuable to have them on board because they could say, John, the classes or the subject matter that you're teaching is something that would be very helpful when a student enters here at SUNY Broome. Also, Jean George from Raymond Corporation is a member of my advisory committee. Jean is Director of Human Resources at Raymond Corporation. David Palmieri is a member of my committee. He works at Lockheed Martin as a senior engineer, just extremely talented individuals. Vincent Ferraccioli is a professional engineer at Delta Engineers, and his specialty is electrical engineering. So just really a dynamic advisory committee that I have. Luke Tucker and Eric Lindquist. Luke is Director of Marketing at EasyRed Corporation, and Eric is a structural CAD drafter at Volcraft Nucor. And Luke and Eric, it always warms my heart when I see them or talk to them. They are former students of my program. So they came here as high school students to study CAD and have been successful in the field and have since been invited to join our advisory committee. So it's really valuable having them on board, because they can remember back to when they were students, like, when they were high school students, like it was yesterday. So really proud to have them on board. Students can get integrated credit at BoCES, and this is a really positive thing. So students can get credit in math, science, or English at their classes by taking their classes here at BoCES. And this can really allow students to free up time in their schedule to take a BoCES program. In the past, this always was a bit of an obstacle before we allowed this opportunity for students, and it's just awesome. However, the CTE, and that's what we're called here, Career and Technical Education, a CTE teacher really does not have much say into what credits could be assigned. That has to go through your component school counselor, who will work with our guidance counselor, Mrs. Butler, here to see that that happens. And I have numerous students that take advantage of this option. Integrated credit, it's called. I love these pictures. So this is a picture of my student Dylan, and behind him is Jaden, and they're just working on some beautiful drawings. And I just love this picture. So if you look on Dylan's desk, the drawing he's working on is this right here. Okay, and this is it's like this machine part, and I'm gonna stop sharing here just so you guys can see this a little bit bigger. And so this is the part that he's working on. It's just kind of like this stainless steel kind of like bracket. And so what he's doing is reverse engineering, which means taking it all apart and seeing how it's built or manufactured. And then he measures it all, with one of these, a pair of digital calipers, which gives very accurate measurements, and then creates a CAD drawing. So this is a 3D CAD drawing of that project that he created. And then we know that we have a great 3D drawing of a project if we could turn it into a 3D print. So in our classroom, we have an additive manufacturing 3D printer, which, unlike most 3D printers that uses a nylon spool and melts it, our 3D printer uses like a white powder and then mixes it with a resin. It just gives for a more higher resolution 3D model, which really just is really nice if you're trying to do something that's super detailed. So, we do have a 3D printer in here that really does a great job. So if we look at this, we have, the 3D print, then we have the actual item, we want them to be like the same size, so we can hold them together, and they line up, and they just look, like the same thing, like it's mathematically accurate. And that is a must. So, Dylan, when he created this, it was a hard project for him to do, but he just did a great job. Here's another project that students work on for reverse engineering. It's an aluminum hub from the aerospace industry. So same thing, we have this, reverse engineer it. Okay, get all the measurements, sketch it out, copy the measurements down, and then create a nice CAD drawing from it. Once we have the nice CAD drawing, and we create a 3D model that way, then we make it available to be 3D printed. So here's the 3D print, here's the real thing. And I hope you guys are looking at them and thinking like, wow, they look very, very good. So the whole thing when you're creating a 3D model or a CAD drawing is its mathematical accuracy. So in here, we pay a lot of attention to the importance of mathematical accuracy, because if the drawing is not mathematically accurate, it can create a whole bunch of problems. It could make your design cause potential failure out in the field, or if somebody's using the product. So just picture a mechanical engineer designing a suspension or brake system for a car, and a real bad thing can happen if somebody goes to push on the brake pedal and nothing happens, because of maybe a poor design or a bracket that wasn't designed correctly or a fastener. And so it's really important to realize that our drawings represent real work. And if we look at architecture, if a person designs a beautiful building, it looks beautiful, but the building falls down as soon as the winds go above 30 or 40 miles an hour, then that's not a good building. People could die or get hurt. So it's important to know that the work that we're doing is completely connected to somebody's safety or a business staying active and viable. So it's just important to know that our beautiful drawings usually always reflect real world work. Here's another example, this like little kind of actuator part right here we have. This is a really detailed little part that just extremely just detailed, very small detail. And student just created a beautiful drawing of it. So, so I'm hoping, that it looks, you can kind of see the resemblance there. And again, once you have that 3D drawing, you can print it out, or 3D model, I should say. So in CAD, we kind of use the term model and drawing interchangeably. Okay, so every drawing is kind of like a model. But so here would be a 3D print of the model, next to the real thing. Okay, so it's just a real I guess important talent for a student to be able to reverse engineer an existing part, create a very accurate 3D drawing of it, and then be able to take that 3D drawing, turn it into a rendered image, which means having it kind of displayed as it looks just like a picture with lighting, shadow, material, and finish, and then being able to take that accurate 3D model and create a 3D print of it. So these are extremely advanced mechanical engineering CAD skills for a high school student to develop. And I would say that that's probably one of the most impressive things about BoCES, is that you will have high school students here, no matter what program they're in, doing the talented work of successful adults. Like, in other words, you'll see a backhoe going across, the parking lot, and there's a high school student at the controls of it. And they're actually digging with that backhoe and doing work with it. We have our building trade students actually like building modular houses and providing them for Habitat for Humanity. Our cosmetology class actually does hair for clients. Like, it's not just like you read in a book here at BoCES, you actually do the work, hands-on, experiential learning. And here we have a saying, we learn by doing. And it's really, really powerful here at BoCES. So you just won't be reading books about CAD drawings or just doing CAD drawings. You will be doing industry standard CAD drawings that are the same types of CAD work that's done out in the business world in architectural and engineering offices, which again will make a student very marketable when it gets time to look for a job. Listeners, I know this is like a lot of stuff to go over, but I just want to kind of go over it real quickly here and to just kind of make sure that I'm giving you a good overview. Some of the more simple drawings that students do when they first come on board, all drawings start in 2D mode. So 2D mode means it just does not look like a picture, it looks like a technical drawing. So this drawing here, if we look at it, is like a front view and a top view. And please notice how they're both totally aligned. And the drawing has dimensions on it and specifications. So these are drawings that students do when they first get here. And many people think that doing this type of drawing is maybe easier than doing a 3D drawing, but it's really not. It takes the same level of commitment, same level of expertise. But one of the things at BoCES is, I think, so powerful is that you do not need to come here with any experience whatsoever. Like, you will be 100% trained from the ground up. You don't need previous experience in like math, science, drafting, CAD, nothing. Like, the only thing that I ask for, my students when they would start here is that they be interested in the program and that this be a career field that they want to study and participate in, and that they, kind of commit to giving it 100% effort, right from day one, from when they start. And to know that everything is connected every day, so that's the most important thing. So no previous experience required. So this would be under the category of a 2D mechanical drawing right here, or an engineering drawing. And then students also, once they do 2D mechanical drawings, they then progress into doing 2D architectural drawings. So this would be an architectural drawing here, and this is our classroom. And so, this is a drawing that students do. And again, it meets industry standard for scale and line weight. And I don't know if you can see on some of the individual desks with the computers on it, so it's a beautiful, accurate architectural drawing. And then this is using a thing, if you look at the title block there, it's using a thing called, it's a floor plan. And a floor plan means you're sitting or kind of like hovering about 5 feet off the floor, looking straight down. And that's what a floor plan is. And all architectural drawings, even, for thousands of years before CAD, used the concept of floor plan. And then they also use the architectural concept of elevation. And elevation is when, like, you're looking at the side of a building or you're looking at a wall straight on. So here's the term elevation. And if you look, it's like looking at the walls of the classroom, and they're denoted by what direction they're facing, east or west. And again, just a real accurate and beautiful architectural drawing. Students have asked me in the business world, is 2D or 3D better? Which one's required more? And the answer is both. They are both absolutely required. You need to be able to do both, 2D and 3D. And it's definitely kind of hard at first, but the more we do anything, the better we get at it. So just want to give everybody a good heads up on those. And then if you look behind me, right here, this is one of my favorite drawings. And so this is a student who created a 3D model of our classroom. And then he's like, would it be possible, like if I had like one of the rendered image, and rendered image means that you're just taking a CAD drawing and making it look like a picture. And he's like, would it be possible to make it like we were doing like a drone view, like flying way over it? And I'm like, yeah, that'd be awesome. And so that's what he did. So this is a 3D CAD drawing of our classroom. And so, this drawing behind me and this drawing right here are they're the same thing. Okay, they're the drawing of the same thing. But certainly you can see that if you're designing a building for somebody, and especially somebody who doesn't or is not, I should say, comfortable in reading a 2D technical drawing, what a beautiful way to show somebody, what your intent is to design by being able to design and render in 3D. And that's the goal with students in this class, that they can do both. Okay, guys, so let me just continue back to sharing. Okay, so that's, let's see. And this was a great day in our class. This is the Deputy Commissioner of Education for New York State, and she came and visited our class. And again, one of the things that we emphasize in this class is students' interpersonal skills, how somebody interacts with other people. And CAD is a very social career field. So we work on that right from the very beginning. And if somebody would have told the student he would be representing the class, giving a presentation to the Deputy Commissioner of Education, I think he might not have signed up for the class. But he just did an outstanding job. It's one of just my favorite pictures. I love this picture. And let's see here. And again, same thing, another student, presenting to her. And if we look in the background, you could just see students working on, some of their projects. Students come into CAD, they get not a school desk, they get a legitimate business class desk to work at. That's their own for the school year. Some of the best computers in the school that are loaded with the best software, and just students are really able to create some amazing projects. Again, here's another student presenting. This is a member of my advisory committee who comes to the class and has interacted with students. And the student's again giving her a presentation of an architectural project that she's working on. And she's using one of our main programs that we use here called AutoCAD. Speaking of college, students can earn college credit for taking this class. We call that Fast Forward, and that's really a great thing that they can do. And there's also some colleges have a thing called articulation agreements, where the college credit's a little bit delayed. Student enrolls in the college, they have to take a couple of classes, pass those classes, then they get the credit. Fast Forward college credit is as soon as the student graduates from this program, they get the direct college credit, and SUNY Broome is one of those schools that do that. We have a national club here at BoCES that students can join. It's called Skills USA, which is just awesome. And then students can take a national assessment. If they pass this national assessment, it looks great on the resume, might help for future employment, so it's a great opportunity for students. And some of the jobs, students can work in architecture, engineering. If you can create architectural and engineering 3D drawings, you can also work in the television, motion picture, or gaming industry, creating both CGI and CGA. Those standing for computer-generated imaging and computer-generated animation. So these are numerous and exciting opportunities. I do want every student to know, though, that some jobs may require additional education. So it's important to know. And I just want to say thank you for coming to visit Broome-Tioga BoCES and computer-aided design, and I really appreciate it. And if you have any questions at all, do not hesitate to talk to your counselor or get a message out to our counselor, Mrs. Butler. If they can give you my email address. I will be more than happy to answer any email. But if you have any questions, definitely make sure you ask it. It's extremely important. But if there's anything I can do for you guys, you let me know.